Array iteration methods provide us an alternative way of looping through arrays. Because of these methods, you will likely never see me create a traditional for loop ever again. We have actually already seen the first one of these methods, which is the filter method. The filter method allows us to filter elements from an array without using a traditional for loop. The benefit of using the filter method, as well as the other methods we're going to be covering in this lesson, is that they clearly indicate what operation we're trying to perform. In contrast, with a traditional for loop, we don't actually know what operation is being performed unless we read through the code. To go over the array iteration methods, let's first create some sample data for us to work with. For our sample data, we're going to have an array of students where each student has a name, a gender, and a height, which is going to be a child object with properties feet and inches. For example, the first entry in this array is going to be myself. I'm a male, and my height is 6 feet 1 inches. For filtering, let's assume we wanted to get a list of all the female students. To do this, we'll first create a variable, and then we'll use the filter method on our array. And for the filter method, we need to provide a callback function, where the callback function will return true if we want to keep the element, or false if we don't want to keep the element. In this case, we need to say student.gender triple equals female. And then we'll print this to the console and run it to verify our code. What we get printed to the console is an array with 3 elements, Sally, Kim, and Cindy. If we look above to our input array, Sally, Kim, and Cindy are the only female students, so it looks like this code is working. If we want to create other filters, using the filter method would be really easy. Maybe we want to filter for male students, or maybe we want to create a filter that filters based on their heights. Doing this would be very simple with the filter function, as it removes a lot of the boilerplate code for us, and we simply need to provide it with a callback function where each student will be provided to that callback function, and the callback function just needs to say whether that student should be kept or ignored. The sum method is used to determine if some element meets a specified criteria. For example, let's say we just want to determine if there is a student under 5 feet tall, or maybe we want to determine if there is a student over 6 feet tall. To do this, once again, we'll create a variable. In this case, we'll name our variable as student under 5 feet. And to do this, we'll say students.sum, and once again, we'll provide a callback function where each student will be passed to that callback function. And in this case, we'll return true if that student's height is less than 5. And again, we'll log the output of this and run our code. When we print this to the console, we get the value false. And this makes sense, as if we look at the heights of all of our students, all of their heights are greater than 5 feet tall. So let's do the same thing, but see if we have any students over 6 feet tall. To determine if any students have height over 6 feet tall, the code was slightly longer, so I formatted it a little bit different. I moved the .sum to the next line so that my one line of code wouldn't grow too long. And then in there, my condition is the student's height.feet needs to be greater than or equal to 6. And then their inches needs to be greater than 0. If their height is exactly 6 feet 0 inches, their height's not over 6 feet. Therefore, we have the additional check on the inches. And when we run this code, we get true for the second log statement, which makes sense as we have at least one student whose height is greater than 6 feet. Now, what's really cool about the sum method is it will short circuit as soon as it finds a condition that evaluates to true. If we look at our first example, none of the students were under 5 feet. Therefore, the sum method would have to iterate through the entire array to actually determine that was the case. In our second example, where we checked if any students are taller than 6 feet, when the sum method is iterating through, the first element actually evaluates to true already. In this case, the sum method would short circuit as soon as it finds an element that evaluates to true and no longer continue iterating through and checking the rest of the elements. Now, similar to the sum method, we have the find method. The find method will do more or less the exact same thing as sum, but rather than returning true or false based on whether it finds an element or not, it will return that actual element. In the find method, we'll do student under 6 feet to make it a little bit more interesting, it's going to look very similar. We'll say .find, and then we provide it a callback function. This callback function, once again, will be invoked for each individual student. And the find method will short circuit and stop iterating as soon as the condition returned is true. In this example, the condition is student's height is less than 6. So if we look at our input array, the first element would return false because height is greater than 6. The second element would return true because the height is less than 6. So the find method should short circuit and stop iterating at this point and return this element. Once again, we add our console log statement, we run our code, and indeed, we do find the element Sally. The every method can be used to determine if every element meets some condition. Maybe we want to do a check to determine if every student is male. To do this, we would say students.every, and once again, we give it a callback function. That callback function will be provided with each element, and in this case, we'll return student.gender equals male. So if the student is male, this will return true. If the student is not male, then this will return false. When we run this code, we get false because not every student is male. Now the every method will also short circuit. However, the every method will short circuit in the case that the callback returns false. This makes sense because as soon as one element returns false, we know that not every element is going to meet the criteria. Therefore, there's no longer any purpose of continuing iteration, as we already know that the every method should return false. Perhaps a more practical example would be if the students had a field to say if they finalized enrollment or not, and we want to check if every student has finalized enrollment, and therefore the class is good to go. The map function is probably one of my favorites. It can be used to apply a transform to each element in the array. For example, we've already created a function that can be used to convert height from feet and inches to centimeters. And perhaps we want to run some calculations where we need to have every student's height in centimeters instead of the current system of feet and inches. To use the map method, once again, we'll create a variable. We'll call students.map. And with this callback function, we can return whatever we want. And effectively what the map function will do is it will provide each element to the callback, and whatever the callback function returns for that element will be what replaces the element in the newly created array. So in our case, our callback function will be provided with the student, and we want to call 2 centimeter with the student's height in feet and the student's height in inches. And when we log the output of this and run our code, we now have an array where instead of each of the student objects, we have their height in centimeters. The reduce method is going to be a little bit different than the rest of the methods we've covered. The reduce method is used to aggregate all of the elements in the array down to a single value. For example, we now have all of the students' heights, so what if we wanted to find the total of all of their heights? To do this, we'll use the reduce method. And the reduce method, like I mentioned, is going to be a little bit different. It's going to have 2 parameters in the callback function. The first parameter is going to be known as the accumulator, and the second parameter is going to be the current element. So basically, as the reduce method iterates through the array, the current student would start as the first element, and then the next iteration, current student would be the second element, and so on and so forth. For this callback function, I will give it a code block for the function body to make it a little bit more readable. And then the reduce method takes in a second parameter after the callback function. In this case, for that second parameter, we'll pass a value of 0. But what that parameter is going to do is it's going to set the initial value for the accumulator. Now, every time this reduce function runs, whatever we return by our callback will be the value for the accumulator for the next iteration. So in our case, we'll say const height in centimeters, and that's going to be 2 centimeter of current student height feet and current student height inches. And then we need to return the accumulator plus the height in centimeters. And when we run our code and print this result to the console, we get 874.65. The for each method is the most boring. It's basically just like any other for loop. You can do whatever you want, but there's nothing really special with the return of the callback function to indicate you're doing some specific operation. So for this example, we'll just go ahead and print each student out to the console. And when we run it, it'll print each student individually. Now I want you to create a mental model of filter, map, and reduce. Assume you have some very large set of data and you want to perform some calculation on that data, such as we did with the total heights. Now when looking at that data, the first thing you want to do is filter any elements you're not interested in. So perhaps you're trying to find the total heights of all male students. So first we would need to filter to only have the male students. And then the next thing you want to do is perform any transforms on that data. In this case, we're not interested in the rest of their data. We're only interested in their height, and maybe more specifically, we want their height in centimeters. So first we'll filter the data we're not interested in, and then we'll perform any transformations necessary to that data. And then the last step is going to be the reduce to aggregate all of the elements down to a single value. So if we're trying to find the total height of our students, the first thing we do is .filter. In this case, we'll filter and keep all of the male students. Now the filter method returns a new array with those filtered elements. So we can directly chain off of this and immediately call the map function. In this case, we're going to map their heights into centimeters. And then lastly, we'll use the reduce method to aggregate all of the elements down into a single value. So as always, we'll log the results and we'll print it to the console. And in this case, the total height of just male students is 344.25. Let's consider if we did this in a different order. If we were to call the map method before the filter method, we would have to do this transform on every element in the array. However, because we call the filter method first, the map method will now only perform the transform on the necessary elements. In our small set of data, maybe this doesn't matter. But in very large sets of data, this can be a significant amount of computation time, especially if you're doing some sort of heavy calculation within the map function. And then to summarize everything again, what we've looked at is array iteration methods. These are going to provide you convenient ways of doing common operations on arrays, such as filtering, transforming, and reducing. There are some additional methods that we did not cover, but these are the ones that I use most commonly.